Okay guys, our next section is going to be transformations. We've done transformations for the last couple of years, but this time we're going to actually plot the correct exact graph, not just a sketch of it, okay? So as a reminder, these are our parent functions. So we have our linear, our absolute value, and exponential, quadratic, square root, rational, cubic, and cube root. Okay, so these are the general parent ones that we start with. And then we do things, we transform it, we move it up, move it down, stretch it, flip it, things like that. We are only going to go through some transformations this year. There are actually more in general that you'll get through for 1050 and calc and everything. So we're going to stick with the basics, but again, we're going to graph the exact function using transformations. Okay, so let's talk about some notes at first. So when we talk about transformations of graphs, there are different things we can do with it. So what we're going to do is we have an a that we can multiply by our function. Okay, so f is our function. We could have a b that is multiplied by x. We can add something to x. We then can add something at the very end. Okay, so each of these little things does something to the original graph. So let's talk about some of these transformations. To do a stretch or shrink, we're going to focus this year on a. When a is greater than 1, we have a stretch. Specifically, it is a vertical stretch. Okay, so some examples are when a is 2 or 3. And don't forget fractions like 5/4. This is greater than 1. Then we have if a is between 0 and 1. This would be a shrink. Specifically, it's a vertical shrink. These numbers are like 1/2 and 1/3. Now, we're not going to talk so much about b this year, but in the case of greater than 1 or between 0 and 1, but if we had another coefficient other than 1 in front here, we would have a horizontal stretch or horizontal shrink. So we're going to talk about that more next year. So now let's talk about reflection. Okay, if a is negative, then our graph reflects across the x-axis. Some of you might remember this, that it flips it down. So when b is negative, so we reflect across the y-axis. Okay, let's talk about shifting. So we're going to talk about c first. If we add c, because we are doing it to the inside here, we are actually going to think of the opposite. So if we add, we're going to go to the left. If we subtract, we are going to go to the right. Then we have a shift with D. this happens to y, we do exactly what we see. So if we add d, we will go up. If we subtract d, we will go down. Okay, so let's look at some things here. We want to remember that when we're doing things to x, we have to do the opposite. Okay? And also, if our transformation is on the inside of the parentheses, and we do it to x. And if it's on the outside of the parentheses, it's done to y. All right, let's now go with all of our rules and see what we can do with our example. First thing I want to point out is our parent function. So this is going to be a cubic. So our parent will be x cubed, and x cubed looks like that. Alright, so last year we just talked about what movement it would make. So right here we are adding 3 to the end of it, so the outside of parentheses, so we're doing it to y. This plus 3 would be an example of our d. So we are adding, and so that means we're going up 3. And then we would have sketched it. We would have taken the middle of our graph and moved it up 3. But this year we're going to do exact values. First thing I want you to do is we're going to start our table with our parent function. So I'm going to use x values of -2, -1, 0, 1, and 2. Okay, these can be any values, but let's use easy numbers. When I plug -2 into the parent function of x cubed, well, -2 cubed is -8, -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So as a reminder, guys, these two are of the parent function. Now, we are on the outside. Remember, it's done to y. So what we're going to do is add 3 to y. So when we add 3 to these coordinates here, I get -5, I get 2, 3, 4, and 11. When there's no other transformations to do to the table, you will graph the outside coordinates. So I'm going to graph the -2, -1, 0, 1, and 2, and the -5, 2, 3, 4, and 11. So if you look, here is a coordinate of -2, -5. So -2, -5, 1, 2, 3, 4, 5. Then I have -1, 2, 0, 3, 1, 4, and 2, 11. When I connect those, you will see that what did we do with our parent function? We went up 3. Okay, let's do another one. Sorry guys. Okay, So in example 2, we have two things going on here. Let's look at our parent function. Our parent function is going to be x squared which is our parabola. We have two transformations. First, on the outside, we have a stretch by a factor of 2. And remember, that's outside, so that has to deal with the y. Okay, I just want to mention that. You don't have to put that down, but then we have this plus 3 on the inside, so that means we do that to x. Remember that? On the inside, we do what's opposite. So this is plus 3, so we need to think of it going left. 3. Okay, those are our two transformations. So now I'm going to start with our parent function coordinates. So let's do this again. Let's do -2, -1, 0, 1, and 2. So we're going up to our parent function, so we're squaring it. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So that's our parent function. What's best to do is usually left to right, but since we only have one against each, it's going to be okay. So for our y, we're going to stretch a factor of 2, so that means we're multiplying our y values by 2. So I'm going to multiply, so 8, 2, 0, 2, 8. Now remember, for our x values, we're going left 3, and we have to do what's opposite. So instead of adding 3 to x, we're going to subtract 3 from x. So we get -5, -4, -3, -2, -1. Remember what I said last time. If you're done with your transformations, you are going to graph the outside. So the very top here and the very bottom are our coordinate pairs that we are going to graph. So I'm going to graph -5, 8. 1, 2, 3, 4, 5. We're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. -4, 2. -3, 0. -2, 2. And of course, I'm off a little bit, so what happened? Sorry guys, I was off. -1, 8. That's why it's good to use a pencil instead of a pen. Okay, one thing I want to keep in mind though, even though this almost looks like you want to do a V, don't forget it's a parabola, so it's curved. A V would be absolute value. Okay, so ignore these extra points because I counted incorrectly. And let's see, did we go left 3? Yeah, and we started to stretch it, so we were pulling it up closer together. Perfect. So this is how you can check your work, guys, that everything matches. Your description matches your graph. Alright, let's try this again. So our parent function in this case is going to be the cube root of x. Let's look at what we have going on. So on the outside, we have a negative. So we're going to reflect. And the negative on the outside says reflect across x-axis. We are going to, the 2 tells us we are going to stretch by a factor of 2. And this minus 4 again is on the outside because there's no parentheses. So we're going to go down 4. Alright, let's do our parent function. Now, the great thing about what I gave you here before is that usually we don't want to use -2, -1, 0, all that stuff that we've been using, because then we can't get perfect cubes. So this is a good indication of what to use. Let's use our perfect cubes of -8, -1, 0, 1, and 8. -8, -1, 0, 1, and 8. So again, I'm using perfect cubes because if we use -2 here, we would get a decimal. Okay, we want to try to do this without a calculator. So the cube root of -8 is -2. Cube root of -1 is -1, 0, 1, and 2. Alright. Let's notice that all of these go to your y's, so we have to do it from left to right. So our -2 is first. Now because that's multiplied, we can do the -2 together. We don't have to do it negative and then multiply by 2. Okay? Because either way, we're just multiplying. So I'm going to multiply by -2 to y. Again, I'm doing that first because I'm going left to right. So I get 4, 2, 0, -2, -4. Then I'm going to go down 4. Again, this happens to y because it's on the outside. So down 4 means I'm going to subtract 4 to y. So 0, -2, -4, -6, and -8. I'm done with my transformations, so I'm going to highlight my outside rows, and these are my coordinates I'm going to plot. Let's see if I can count correctly this time. -8, 0, so -8, 0, -1, -2, 0, -4, 1, -6, and then 8, -8. Not as smooth. I need new pens, guys. So one thing I forgot to show you is that the cube root, if you go back to that first page, looks something like this. So let's see. Did we flip it? Yes. We probably stretched it. It's kind of hard to see there. And then did we move down 4? Yes. Alright, now let's see if we can create our own functions knowing our transformations. Okay, so let's think of this. When we do a vertical shrink by a factor of 1/2, we are multiplying by y. Okay, so you're doing it on the outside. When we reflect across the x-axis, that makes a multiply of a negative to our y. When we shift up 4, up means we add 4, and that's our y. I'm saying y, but I also mean outside. So let me put a note on the side. Y means outside parentheses. Okay. So when I do my function, remember in front is all of our multiplication stuff. So it's 1/2 and it's negative. This is where we would usually put our parentheses, but since we don't have anything to do inside the parentheses, I'm just going to put the parent function. And then on the outside here we add 4, and we're done. Example 5, vertical stretch by factor 3. We're multiplying by 3. That's to the outside, right? I'm going to put outside this time instead of y. Shift down means we subtract 2, and again that's outside. And right, well remember, think of opposite. Right is -4, and that's inside parentheses. If you're not remembering inside outside, guys, go back to your first set of notes. Alright, so let's look at this. F of x, on the outside we have 3. We have our parent function, which really is our parentheses, right? Have our x. Now on the inside here, we're subtracting 4. Okay. And on the outside here at the very end, we're subtracting 2. Another way you can see this, and I'm going to write it over again, is that 3 could actually be in the numerator, because 3 times 1 is 3. Alright, grab your practice work. Ask questions when you need, guys.